Hello everyone, welcome back to another episode. And in this video tutorial, I will talk about how stochastic fractal search optimization algorithm works. So in our previous videos, like genetic algorithm, artificial bee colony, particle swarm optimization, we just minimize a simple objective function. And in this video tutorial, I have considered load flow analysis as objective function, and the optimization algorithm right over here is stochastic fractal search. So in this video, I will focus on the optimization algorithm instead of the load flow analysis, as the load flow analysis is done in a separate video, which I will just mention right in the right top right of this video. You may take a look at the I button to watch that video. So this video is about the stochastic fractal search optimization algorithm. So let's start with that. So initially we have just mention or start global variables inside the right over here. So let me click on continue. So the difference between a simple variable and a global variable, when we switch to another function files right over here, we are switching to this script file, which is actually the sfs.m main file. So right over here, we are switching to that script file. So whenever we script to another script file or another workspace, normally our variables, the variables which we have initialized right here, for example, that will not be appeared right over here in that script file. But the advantage of that global variable is that when we run this program and we have initialized the global variables in which we are workspace or we are into another function file, we can still utilize or update these numbers. So that's the advantage of that. So let me start with the program. Let me click on continue. So right over here, it's a case where we have to define our load type and the power factor which we want to consider. So let me assume 0, as we are not going into much depth of load flow and program. So, and let me consider the power factor and iteration as 100, population 50. Okay, right over here. Okay, so these variables are actually saved inside the s variable. Okay, we are already into the s, so let me open the s. So here you can see the variables which we have initialized, or we put a user data by using these input prompts. So the data which we put right over here is stored into this. And here there are some SFS function variables which are initialized. Let me talk about a little more about them. This is the maximum diffusion. Maximum diffusion actually is sets the diffusion value which will control how far a candidate solution can move away from the current solution in each iteration. I will talk about it more in a little bit. And diffusion is actually the main part of this program. And then there is a walk which determines the step size or walk length for candidate solution, function name which is dg1 sfs. Here you can see that this is the function file. So in function file we have load flow analysis part. Okay, right, this is the ndim, which actually represent number of dimensions in the search space. This is the lower bound for each dimension, and this is the upper bound for each dimension of the search space. And then there is a plot, controls whether or not the algorithm will generate plot during the optimization algorithm. Show results, determine whether to display the optimization results. And then there is start optimizer, starts a timer to measure the execution time of the optimization algorithm. So that's how this is the end optimizer, and this will tell us about the time tick and talk. Means we are calculating time for this function, how much this function takes time. So this is actually the main function. So let me click on continue. Right over here, let me close that. Into workspace we have all the start optimizer and volter. So the start optimizer is not a global variable, and now when we switch to this function file, uh, all the all the global variables will be there, but this start optimizer will not be there. So right over here, we are putting all the data inside the S. We are sending this variable S into stochastic fractal search .m file. Let me left click here and let me click on step. I think so that's a different file. Let me click on pause. Let me again run the program. 0.6 any. So now we are into this stochastic fractal search. So in stochastic fractal search, we have input our data as here, right over here, and this is the input data which we have put into our stochastic fractal search program, and this will be the output which we have to uh, take from this script file. And by using all this script file, we have to get these data from this file. So here is the p best, which actually represent the best solution for the problem. F best, best fitness function, and f recording the value of the best fitness function. So this is a point the inside the considered search space, where we have to create a numbers by using the repmat. How repmat works: repmat actually is used to create numbers or arrays based on the data which we provide him. So here you can take a look about the repmat. So by using repmat, we are going to create random points by using the minimum and the maximum range for our considered search space. Let me click on step. Okay, so here you can see in our point we have 50 numbers. So these are the 50 numbers which we have to put into our objective function or into our load flow program. And then there is right over here, the numbers, initial numbers which we have created right over here. Now we have to calculate the fitness for these numbers, fitness for these 50 numbers. So here there is a call for the s dot function, which is actually the function name. So function name is right over here, is the dg1 dot sfs. So another command that is used here is the feval. So again, let's search about the fev evaluate function with the function name as character vector. So from this example, you may take a look at that. The we have just name round as the function, and pi as the x1. So our round, which is actually the function is representing the round. So we want to round our pi, so which is actually 3.14, and that's actually becomes the 3 because it's less than 5. So right over here, by using the feval, we have our objective function. So right over here, we want to evaluate our objective function, and for that objective function, these are the inputs which we want to put into the function, into this function file, which is dg1 sfs. So for in dg1 sfs, we will send one by one data. This one 31.67 first time, and dl and the power factor. We will send that data into our function file program, and this loop will repeat itself for 50 times. So we have 50 numbers, and after the execution is of this loop, we have 50 fitness values. So let me show you that. Click on step. Right over here we are into this program, and here we have the data right over here which we send into our load flow program, and the rest of the part will calculate the power losses utilizing right over here the power factor, and here's some calculation for the power loss calculation, and then updating the global variables right over here. And then there is some output, which output actually is the output of this program. Okay, so let me click on step. Okay, let me click on, let me click on continue. So let me click on step. So first fitness against this first number 31.67 which we have, which we inject in that program, is 199. So this loop will be run for 50 times. Let me click on continue. So right over here we have 50 fitness values. Now there is a sorting process, and after sorting, let me click on continue. So after sorting point, here you can see the first number we have sorted. The first number is the best number because in that we get the less power losses. So click on step, click on step. So right over here, this is the minimum cost or minimum power losses which we get right over here is the process. And then there is a starting optimizer, and there is a diffusion process. Let me click on continue right over here, and at this point we are going inside the diffusion process. So this is the data for the diffusion process. Diffusion is actually the main process within this SFS. So in SFS, the diffusion process actually determines how far a candidate solution can move away from the current solution in each iteration. And here is the MATLAB code for that. So it actually controls the exploration of the search space. So here we have to change our input data. Change our input data means the data which we have initialized right over here by using the point, that is actually the input data or the initial points, and then we get fitness by using this function. So we have our input, we have our points, and we have fitness for that. And right over here in this in the diffusion process, we have to update the points, and you can see that the points are used here. We have to update the points, and we have to generate updated points which give us the better fitness value for that. So that's it's all about. And again there is FVAL, and there is a function call and a new point. Here you can see that we have update our points. So right over here we update our points and finding the fitness value for that using the available data right over here. So at the end of this program we have create our points, and we have updated our points and the fitness which we get using this function file or the program. So let me move back to this part right over here, and let me end that program. Let me click on continue. Right over here we have the diffusion, and this is the size which we want to inject into our load flow program, and this is the fitness which we get right over here. And again updating the best points obtained by the diffusion process. There is a sorting process right over here as it's done previously, starting the first updating process, and then there is a comparison between the initial points and the new points. There are some random calculations which are the part of this SFS optimization algorithm. And at the end of this program right over here again some sorting and finding the best one, best results as per each iteration. And at the end of this program, right over here, we have find our p best, f best, and f. So this is actually the main loop. So this is the loop. So for the maximum iterations, this will be, let me click on continue, and right over here click on step. Okay, now we are back into the SFS, as this loop have to be repeated for this will be run again and again up to 100 times, and then this will be we will get our final p best, f best, and f. And in our main program, let me click on continue, remove that. This is some kind of error. Let me break the program and let me run again. Let me click on continue. Yeah, it's taking some time to go up to that point, and it takes a little bit time. Normally when optimization, the MATLAB program is not working correctly, just restart the program. Okay, we are right over here at this point, and using the data which we get from the main sfs.m file, pbest, fbest, and f, and now we have to display our results. So let me click on continue. So here our power losses and the location and the size, and dg2, if we this is using the one distributed generation, and then there is another function file for dg2f sfs. So if you want to utilize for 2 dgs, you have to consider this as the function name file. So this is the point where we name our function file. So if you want to consider go with the 2 distributed generation, you have to change here the function name. So that's how it work, and I will upload this program on the website, and I will put the link in the description. You may go and take a look at the code. So please like the videos and subscribe to channel, share the videos, as I'm not getting enough likes on the content, and the efforts I'm putting right over here in the videos, I'm not getting any response. So I'm just looking for more likes and shares for this content, so that will be a little motivation for me to create more such videos. So thanks for watching and stay tuned.